Hi, I'm Colin Walls and I'm here once again to talk about embedded software. Today I'm going to take another look at a facility of real-time operating systems. And today's feature I want to consider is partition memory. This is a function which is available with most real-time operating systems, and it's aimed to address some of the challenges you can have when developing a real-time application. So, what problem are we trying to solve? Well, first of all, it's very common in any kind of application to want to allocate some dynamic memory. Now, the usual way of doing that in C would be to call the function malloc. That's fine, but there's two problems with malloc. Number one is what happens when failure occurs. In other words, if there's no memory left for an allocation, you simply don't get any memory allocated and you're stuck. Next problem is the timing of malloc. It isn't necessarily, in fact it's almost never, deterministic. So you allocate some memory and you have no real idea how long that allocation will take. The third problem with malloc is more subtle, and it's to do with fragmentation of the heap. Now, the heap is the area of memory used by malloc to give you the allocations you request, and this can go wrong. Now, if you imagine an example, we have a heap which is just 10k long. That's quite small, but it gives us an example. We call malloc and we allocate a 3k chunk of memory. Okay, so far. Then we allocate another chunk of memory which is 4k long. Again, that's fine. So we've got 7k allocated, 3k is free. Then we deallocate the initial 3k. So now we have 6k of memory free. Fine. We then try to do another allocation of 4k and it fails, even though we've got 6k free, and the reason is we don't have 4k of contiguous memory. And it's impossible to do housekeeping on the heap simply because we can't move things around, because people won't be using pointers to the areas of memory, so we can't tidy things up. So the heap has become fragmented and therefore we can't make proper use of it. This is a problem. Partition memory is a solution to it, and the way it works is you can make calls to the operating system to ask for dynamic memory, and what it gives you is a fixed size chunk. Now typically you'll have multiple partition pools. Each one provides chunks of different sizes, and you make the appropriate call to grab a chunk of memory. This has the advantage that it will be deterministic. Being a real-time operating system API, you would expect it to be predictable in the timing it takes. It also has no possibility of fragmentation because there are fixed size chunks, so there's either a chunk available or there isn't. There's no intermediate possibility. If failure does occur, in other words, if you run out of chunks of memory in a given partition, then you have the option of suspending a task. Again, so when you make the API call, you can specify that instead of failing, just suspend the task that it's available, which is containing the fault. That's the idea of partition memory. It's very simple and straightforward. There are more sophisticated aspects of it, of course, and this is something which I write about commonly, and you'll see the opportunity to get more information on that as and when. So that's it for today. I'll be back soon with another embedded software topic, and I'll see you then. Bye for now.